please support me through PayPal to devinwyndham@gmail.com. devinwyndham@gmail.com is one word, all lowercase. I also do tutoring, so if I tutor online and in person. I'm based in Fairfax, Virginia. If you're interested in tutoring, you can reach me at that same email. Please subscribe to my channel. I'll leave all this information in the comments. Alright, right now I wanted to talk about the fact that I'm thinking of redoing my proof on YouTube of the sum formula for sine. In other words, the sine of a plus b equals sinAcosB plus cosAsinB. I was thinking about it this morning and I thought of a simpler version. Basically what this, what I'm going to prove it is, so now think of the unit circle and then think of a point B on the unit circle. Let's just say in the first quadrant, to start out to make it easy. And we're going to imagine what happens when we rotate B, when we subject B to a transformation, namely a rotation by an angle of A. And B, you know, obviously is the angle B in that identity, but I'm thinking of it as the associated point on the unit circle for now. Now imagine a vector emanating from the origin with its head resting at B, so it's like B's vector. Now break B into component vectors along the x and y axes. So we have a component vector along the positive x-axis and along the positive y-axis, again if our point B is in quadrant 1. Now, let's consider the identity that we're going to prove. The left side is sine A plus B. So, if you think about it, what we're looking for is, it's the y-coordinate of that point B after it's been subjected to the transformation of rotation through an angle of A, right? So, that simplifies the problem. And if you think about it further, we can find that y-coordinate by summing the y-coordinates of the two component vectors. So the problem is, I think, a lot easier now. Let's start with the x component vector. What is its y? Its initial y component is obviously 0, but what is its y component after the rotation through an angle of A? Well, if you think about it, its y component, basically that initial x component vector of B is cosine B, right? It's cosine B, and its y to project. We'll project that on the y-axis. In other words, we'll rotate it and project its, we'll call it the image. It will be the result of the rotation. So we'll rotate the x component of B and we'll find the y-coordinate of that image if we do multiplied by sine A, right? Cosine B sine A. Well, that's just the first term on the right side of the identity, right? Okay, and now consider the y component of B. What happens to it? Well, the y component of B, it basically already is is its y coordinate. What's the y coordinate of its image under that rotation? Well, the y coordinate of the image is it's cosine A sine B, right? That's a little bit hard to think about, but it's y coordinate about projecting on the y-axis. Its y coordinate is cosine A. Its y coordinate is cosine A sine B. Alright, so that's basically the proof. It's going to be the proof.